All right, let's try letter B here. Again, we need to find the solution, and then of course the general solution, and there's always something like this here, but you don't need to worry about that part. We just need to solve this equation. So we need to get the tangent alone, so we can divide both sides with the square root of 3. Note we cannot divide by 2 because it's inside the tan, so that has to stay. So I get 3 over root 3. So I look at my chart, 3 over root 3, and where is it here? So I have 1 over root 3, that's not 3 over root 3, and I have root 3, so I don't even see any of the greens that say that. Okay, well that must mean that I can't have a square root on the bottom, so maybe I should just change this. So times by that, which would equal root 3 over root 9, and root 9 is just 3. So root 3 over 3 is, sorry, no, that's not even true. It's 3 times root 3 is a 3 root 3. And yeah, because top times top there, 3 times root 3 is 3 root 3. Root 3 times root 3 is root 9. That is just a 3. And now the 3's can cancel out, and you're left with just the square root of 3. So I'm trying to find the square root of 3 for tangent. Take a look at the green. Square root of 3 right here. So pi over 3. So pi over 3 is my angle that I need to reference. So I'm going to create this chart, and I'll do 3 over 3 and 6 over 3. That's my pi, and this is my 2 pi. And because it's tan, technically I only have to worry about pi, the first half, but I'll probably just do all of it. So let's take a look here. I need when tangent is positive. So it's positive here and here. And so these are my two angles. And I know this to be pi over 3 as a reference. And pi over 3 as a reference. So this angle, well, that's just pi over 3. And then the other one here, 3 pi over 3 plus another pi over 3, which is 4 pi over 3. So normally that would be it. I would just have those as my two answers. I'm just going to move this here because apparently I got a little aggressive in my writing and took over a lot of space. So pi over 3 and 4 pi over 3 are my answers. That would be my normal answer, but that's when I have x, but I don't have an x, I have a 2x. Now, like I said before, you could divide by 2, but I'm actually going to times by half, because I don't like having a fraction divided by a number. So the numerator and denominator will still cancel out, and x is equal to pi over 6 and 4 pi over 6. Now, you could reduce this 4 pi over 6 if you wanted to 2 pi over 3. Now for the general solution, you can have both of these. Is it 4 pi over 6? I'm just double checking. Oh yeah. Both of these, but you're going to need to add the period. So that's 2 pi. Oh, is it tangent? It's tangent, so it's just pi. Pi n. Now that's what it normally would be, but these are not normal questions. And so for this, we need to keep in mind that the period is pi over b, not 2 pi over b because it's tangent. It's pi over b. B has almost always been 1, but in these three questions, the period changes. B is now 2. It's the number here. So it's a 2. So my period is pi over 2. So I'm going to make that as pi over 2. And then that's all I need to do. So pi over 2, I'm just double checking, 3 pi over 6. Yep, that works. So that would be your answer. So what's different about this question than all the ones that we did? Well, nothing until the very end. You just have to know you can't divide this 2 away. That 2 gets dealt with right here. So when you have your final two answers, they're not x equals, it's 2x equals. So then you got to times by a half to get your real two answers. And then when you do your infinite, you don't just do pi n, because it's tangent, you don't just do pi n, you have to divide it by the 2. pi over b, pi over 2. So those are the two major changes in this question. So we're going to do another question just to kind of repeat this as well. So we're going to divide. I mean, maybe I'll just zoom out here in case you want to take a look and pause the video for b if you need to copy anything down. But let's try c now. Divide by -2. So I have sine of x over 3 equals -√2/2. Now, I can't times by 3 to get rid of this denominator of 3 because that's inside. So I'm going to have to deal with that later. So when does sine of x equal √2/2? So sine is on the right. √2/2 is here. So my reference here is pi over 4. Okay, so pi over 4 is what I'm going to reference. And so when I do this, I'll make this 4 pi over 4 and then 8 pi over 4. So now I need to draw which quadrants I'm in. So I'm when sine is negative. So it's negative here and here, not these ones. So these are where mine are. And I have these as referenced as pi over 4, and this one's pi over 4. So what are my angles? Well, this would be 4 pi over 4, but it's a little bit more, so my answer is 5 pi over 4. And this one would have been 8 pi over 4, but it's just shy, so it's 7 pi over 4. So those are my two answers. And normally it would be x equals that, but I think it's x over 3. Yeah, it's x over 3. And so for this, I'm going to times both sides by 3 on the numerator so that it cancels out. So I'll times by 3 on the numerator and on the numerator. And so it looks like what I'll have is x equals 15 pi over 4 and 21 pi over 4. Now the period for this thing is always, because it's sine, it's 2 pi over b. In this case, b is what? Well, b is not 3, it's 1/3. So 2 pi divided by 1/3. And so when you're dividing by a fraction, you can flip the fraction, turn it to a multiply, which gets you 6 pi. So that's really tricky, because you think, oh, it's just a 3 there. But it's not really a 3, it's a 1/3. Your b value is 1/3 times the x. So the 1/3 is your number there. And when you divide by 1/3, same thing as timesing by 3. So when we do our infinite solutions, we're still going to get that 15 pi over 4 or 21 pi over 4. But then for both of those, you can add as many times as you want 6 pi. And times where n is an element of the integers. So there are some of the practice worksheets that I would recommend doing, but that's it for all of this. So I'll just zoom there if you want to copy anything down, but again, the PDF's a little bit nicer. But I think that that'll be it for this. There's no more questions, right? No, that is everything. One of the things I actually forgot to mention here is that tan has some problem spots, and that's because tangent is sine over cos, and cos is a denominator, and it cannot equal 0. So very much like this one here, where we had sine over x, tan is sine over x, cos of x can't be 0. Therefore, what angle could you put in here that makes cos 0? Well, pi over 2 or 3 pi over 2. And once you do that, it's always the same. Cos of x cannot equal 0 because it's always on the denominator. Except for us here. Because in this one, we have tan of 2x. Now tan of 2x is the same as sine of 2x over cos of 2x. So instead of having cos of x equals 0, can't equal 0, we now have this denominator. Cos of 2x cannot equal 0. So it's changed a little bit. Now, what angle gets you 0 for cosine? So you can look at your chart, wherever that is. Cos is on the left. So 0 is here at pi over 2, like I already said. And down here, 0 at 3 pi over 2. So it's at pi over 2 and 3 pi over 2. So the angle would be pi over 2 and 3 pi over 2. Just like I said before, they're always the same. Except for in this case, this whole thing can't be pi over 2. So 2x cannot equal pi over 2 or 3 pi over 2. And very much like what we've been doing, you can times everything by half. So then those are gone. So the actual angle that you cannot equal is pi over 4 and 3 pi. 3 pi times 1 is 3 pi, and 2 times 2 is 4. And that doesn't actually have any bearing on our question here because our answers were pi over 6 and I guess 2 pi over 3, but 4 pi over 6. So there's really nothing to worry about. But I thought I would at least add it in just as a reminder, and you'll see that on the PDF that I've written this. It has no bearing on this question, though it could. Very much like over here, we had to reject a question. I can't remember where it is, but we had to reject a question just because it conflicted. Oh yeah, this one right here, example 4b. We had to reject this part. So we got to keep that in mind, but it's not completely necessary it is necessary, but it doesn't completely change the question.